Good morning, students. As you are aware, we are meeting after some time, and now we shall be starting your next topic from your geometry unit, that is quadrilaterals. We have done lines and angles, we have done triangles, and now we come down to quadrilaterals. All of you have in class 8 discussed about the properties of quadrilaterals. What is a quadrilateral? Quadrilateral, a four-sided closed figure. There is board in front of us. It is a quadrilateral, isn't it? It is a rectangular shape, right? Then square, parallelogram, trapezium, kite. These are all regular quadrilaterals whose properties you have studied in class 8. Square, opposite all sides are equal. Rectangle, adjacent sides and these and that. Everything, all the properties of the square and you have studied, right? So now we are going to discuss about other properties of a quadrilateral. In your exercise here in class 9, we are going to specifically discuss about parallelograms. So parallelogram, we all know what is a parallelogram. Parallelogram is a special type of a quadrilateral in which each pair of opposite side is parallel to each other, parallel and equal. A, B, C, D. Opposite sides are equal and parallel. Yes? Right? If we talk about parallelogram, opposite angles are equal. Angle B is equals to D, C is equals to A. Right? The diagonals of a parallelogram bisect each other. If this is one diagonal, this diagonal divides this parallelogram into two congruent triangles. Congruent triangles, we have just completed the chapter, and this chapter is also based on the properties of congruencies of triangles. Right? So you can see CD is equals to AB, AD is equals to BC, angle B is equals to angle D. So we say that they are opposite sides of a quadrilateral. Right? So therefore they are a congruent triangles. These are the properties are given to you in theorem from 8.1 to 8.8 of your textbook. I have also uploaded a document of all the theorems together. You can check the documents from 8.1. All the documents of this, all the theorems of this chapter have been uploaded. Right? So here we are going to basically discuss about parallelogram and its properties. Parallelogram, you can see opposite sides of a parallelogram are equal and parallel to each other. Then we have another property of quadrilateral. We know the vertices, all the four vertices give the sum how much? 360. Sum of angles in a triangle 180. Sum of angles in a quadrilateral 360. These all properties you have studied in class 8. They are not new. Now we are going to discuss about specific properties of a parallelogram. Page number 146 of your textbook, exercise 8.1. You find the questions based on that. Exercise 8.1 of your textbook. Page number 146. First question. The angles of a quadrilateral are in the ratio 3:5:9:13. We know. What is the sum of angles in a quadrilateral? 360. So sum of all these angles 3x, 5x, 9x and 13x is equals to how much? 360. We can find x. Not an issue. Isn't it? Now we are coming down. We are leaving these questions 2, 3, 4, 5 for some time. Take a look at question 9, 10, 11, 12. They are all based on the properties that we have discussed in triangles. You just have to observe. Figures are given to you. We'll draw the figures and we'll see. Check for example. In a parallelogram, question number 9. In a parallelogram ABCD, 2 points P and Q are taken on diagonal BD such that DP is equals to PQ. Question number 9. This is a parallelogram. A, B, C and D. He is telling you it is a parallelogram. If it is a parallelogram, what are the properties we know about this parallelogram? That the opposite sides are equal and parallel. AD is equal and parallel to BC. AB is equal and parallel to CD. Can he say that? Yes. Then he says P and Q are the points on the diagonal PD. P and Q. This is P and this is Q. Such that dP is equals to dQ. That is also given. So what are the quantities given to us? Let us write it down. Given A, B, C, D is a parallelogram. This is the symbol of parallelogram. And dP is equals to BQ. What you have to prove? You have to prove certain things over here first. Triangle DP APD congruent to CQB. Triangle APD congruent to triangle CQB. Second, AP equals to CQ. Third, triangle AQB is congruent to triangle CPB. Fourth, AQ equals to CP. And fifth, APCQ is a parallelogram. These are the things he wants us to prove. See, I have not drawn the figure completely. Figure is there in front of you. You have to analyze that figure very, very carefully. Right? Write down what are the things given to us. For example, construction not required anything. Everything is constructed for us. Proof. In the previous chapter also we had discussed whenever things are given to you, write down whatever is visible. First thing visible that ABCD is a parallelogram. If it is a parallelogram, opposite sides are equal and parallel. Write it down. Because ABCD is a parallelogram, therefore AB is equals to CD. AB is parallel to CD. Then BC is equals to AD. BC is parallel to AD. Opposite sides of a parallelogram are equal and parallel. Right? Now observe, what does he want us to do? APD congruent to CQB. Where is APD? APD. Can you see this triangle? And CQB. Can you see this triangle? Take it. In triangle APD and triangle CQB. Just observe. If you observe it carefully, you will not find any difficulty. You have to observe. You can see, is this AD equal to BC? Given to us, AD is equals to BC. AD is a part of this triangle. AD is equals to BC. Opposite side of a parallelogram. Then, is this DP equals to CQ? DP is equals to DQ. DP is a part of this. DP is equals to DQ. And two sides are equal. Which is the third side? Third side, sir, is AB and CQ. They are not equal. We don't have a relation. And that is what we have to prove in the second part. So AB is not equals to CQ. So let us find out the angle now. So you can see this AD is parallel to BC. Is this BD a transversal? So is this angle equal to this angle? Reason, alternate interior angle. Angle number 1 and angle number 2. Angle number 1 is equals to angle number 2, and this both reason given to us. And here alternate interior angles. So therefore triangle APD is congruent to triangle CQB. By what congruency? SAS. Check. Side, angle and side. Two sides are equal and angle between the two sides is also equal. And if these two are congruent, these two triangles are congruent, is the third side AP equal to CQ? AP is equals to CQ. So AP is equals to CQ. Reason CPCT. I don't need to discuss all these topics again, CPCT and SAS. We have discussed deeply in the previous chapter. Right? So two parts are there. First, second, third part. Triangle AQB. In triangle AQB and triangle CPD. See, this is all class previous chapter, nothing of this chapter, chapter. This is all of previous chapter triangles, congruency of triangles. AQB, AQB, so this is the triangle. This one, and CPD, this one. Observe, is AB equal to CD? Given to us AB equal to CD. Then is this BQ equals to DP? BQ is also part of this. AB is equals to CD and BQ is equals to DP. Both of them are given to us. Two sides are equal. AB and CD, BQ and DP. DP is a part of this triangle, BQ is a part of this triangle. Can you see that? Now, secondly, which angle? Can you find another angle? Can you see this angle equal to this angle? Angle number 3 equals to angle number 4. Reason same. Alternate interior angle. AB and CD are parallel lines and BD is a transversal. And angle 3 is equals to angle 4. Alternate interior angles. So therefore, triangle AQB is congruent to triangle CPD by what congruency? SAS, same. And if it is congruent, is this side AQ equal to CP? Reason CP, CP. So therefore, AQ is equals to CP. Reason CP, CP. Third and fourth part done. Now what? Last part, APCQ is a parallelogram. Check. APCQ. Can you see, is opposite side AP and CQ equal? Yes. Is the opposite side AQ and CP equal? Yes. In a quadrilateral, if opposite sides are equal, then it is a parallelogram. Now, in quadrilateral APCQ, opposite sides are equal. That is, you can see AP is equals to CQ and AQ is equals to CP. Right? Can you see that? Proved above. Proved above. Therefore, APCQ is a parallelogram. Why? Opposite sides are equal and parallel. How do we know, sir? Take a look at theorem number 8.3. If each pair of opposite side of a quadrilateral is equal, then it is a parallelogram by theorem number 8.3. If each pair of opposite side of a quadrilateral is equal, then it is a parallelogram. Can you see that? Clear? So all of them is your observation based on 7th chapter, and last statement we have to check whether it is a parallelogram or no. Right? Question number 10. Same. ABCD is a parallelogram. AP and CQ are perpendiculars from vertex A and C. Question number 10. ABCD is a parallelogram. A, B, C, D. I suppose it is marked in such manner. Yes. And it is a parallelogram, so opposite sides are equal and parallel. Let us mark over here, so it is convenient for us. And then AP and CQ are perpendiculars. AP is perpendicular on the diagonal and CQ is perpendicular on the diagonal. Right? Observation, only observation. What is given to us? We are given parallelogram ABCD in which AP is perpendicular to diagonal BD and CQ is also perpendicular to diagonal BD. What we have to prove? Is he saying that they are equal? No. Show that triangle APB is congruent to CQD. What you have to prove? You have to prove first triangle APB congruent to triangle CQD, and second AP equals to CQ. Construction not required, everything is constructed for us. Proof. triangle is talking about APB. APB, this triangle, and CQD, this triangle. In triangle APB and triangle CQD, just observe. Is this angle 90? Yes. Is this angle equal to this angle? Angle number 1 equals to angle number 2. Angle number 2 is equals to angle number 1. Reason, alternate interior angles. Then angle P is equals to angle Q is equals to 90 given to us. Can you see that? And is the side AB equal to CD? Side AB is equals to CD, opposite side of a parallelogram. So therefore, triangle APB is congruent to triangle CQD by what congruency? AAS. Some of us say, sir, can it be RHS? RHS means right angles are 1 angle is 90. Opposite to right angle, hypotenuse is equal. But S stands for side. There is no side. Is this AP equal to CQ? No. Is this PB equals to DP? No. Right? So it cannot be RHS, it has to be AAS. Two angles are equal and one side is equal. First part done. And if these two triangles are congruent, is this perpendicular AP equals to CQ? So therefore, AP equals to CQ. Reason, CPC. Right, students? So observation is very important. In your geometry, the most important part is your observation. How you observe the figure. If the observation is perfect, you will not find any difficulty. Right? Take a look at question number 11. It is the same. If you observe it carefully, it is the same. Very easy question. In the given figure ABC and DEF, AB is equals to DE, AB is parallel to DE, BC equals to EF, BC equals to parallel to EF, and vertices ABC are joined to vertices DEF. Show that. 6 things he wants us to prove. So 6 things he wants us to prove. If we draw the figure, it is very easy. Let us draw the figure. Question number 11. ABC and DBC are two triangles. Sorry, ABC and DEF. This is the figure. A, B, C, D, E, F. He says AB equals to DE, AB parallel to DE, BC equals and parallels to EF. These are the quantities given to us. What is given to us? We are given in triangle ABC and triangle DEF. AB is equals to DE, AB is parallel to DE, BC is equals to EF, BC is parallel to EF. Now we are joining B to E, A to D, and C to F. Right? We have joined it. Correct? So what are the things he wants us to prove? He wants us to prove 6 things. First, quadrilateral ABED is a parallelogram. Quadrilateral ABED is a parallelogram. Second, quadrilateral BCFE, BEFC is a parallelogram. Third, triangle, AD parallel to CF, AD equals to CF. AD parallel to CF and AD equals to CF. Fourth, quadrilateral ACFD is a parallelogram. Quadrilateral ACFD is a parallelogram. Fifth, AC is equals to DF, AC is equals to DF, AC is equals to DF. And sixth, triangle ABC congruent to triangle DEFC. Very easy question, not difficult, only observation. And application of theorem 8.8. 8.8 theorem on page number 145 of your textbook. Page number 145 of your textbook. Just check that theorem. It says that in a quadrilateral, a quadrilateral is a parallelogram if a pair, means one pair. If a pair of opposite side is equal and parallel, if a pair of opposite side is equal, means one pair. So check the quadrilateral. First quadrilateral ABED. We know, what do we know? A quadrilateral is a parallelogram if a pair of opposite side is equal and parallel. So therefore, in quadrilateral, first one ABED, where is it? ABED. Can you see AB is equal and parallel to DE? Given to us. In quadrilateral ABED, AB is equals to DE, AB is parallel to DE. So therefore, it is a parallelogram. Isn't it? A pair of opposite side is equal and parallel, and that is given to us in the question. Only observation. Only thing we have to open our eyes and see. Only observation. Now, since it is a parallelogram, AB is equals to DE parallel to D given to us. Will this BE be equal and parallel to AC as well? Yes. So therefore, BC is equal to AD and BC is parallel to AD. This conclusion we can come. Similarly, quadrilateral BEFC. In quadrilateral BEFC, observe. BEFC, is BC equal and parallel to EF? That is also given to us. BC is equals to EF, BC is parallel to EF, so therefore it is a parallelogram. And if it is a parallelogram, the third side, is this CF equal and parallel to BE? So CF is equal to BE and CF is parallel to BE. Right? Clear? Now he says, show that AD is parallel to CF and AD is equal to CF. Check, observe. AD was equals to BE. Look at it. This and this. Just observe carefully. Do you find that AD is a common? BC, sorry, not AD, BC. BE is equals and parallel to CF and BE is equal and parallel to AD. BE is equal and parallel to AD, not BE, BC, not BE, BE. Right? So observe it. Yes? Can you see BC common in both of them? BE is equals to AD, CF is equals to BE. So from equation first and second, I name it equation number first and equation number second. From equation first and second, BE is equals to AD and BE is equals to CF. So therefore, AD is equals to CF. Similarly, BE is parallel to AD, BE is parallel to CF. So therefore BE is parallel to CF. Right? Any confusion? If two sides are equal, then third side automatically becomes equal. Lines equal to the same line are parallel to the same line. Theorem number 6.6 of lines and angles. Isn't it? So these are the observations. Now he says quadrilateral ACFD is a parallelogram to observe. Where is ACFD? ACFD. In this, do you find AD equal to CF? Yes, AD equal to CF, B equals now, because in quadrilateral ACFD, opposite sides are equal and parallel. Reason: AD equal to CF, BE parallel to CF. Sorry, not BE, AD parallel to CF. Right? So therefore, ACFD is a parallelogram. By which theorem? This theorem is applied. Theorem number 8.8 of your textbook. If a pair of opposite sides is equal and parallel, then it is a parallelogram. If a pair of opposite sides is equal and parallel, then it is a parallelogram. If a pair of opposite sides is equal and parallel, then it is a parallelogram. Now, if it is a parallelogram, is this side also equal to this side? So therefore, AC is equals to DF, opposite side of a parallelogram. And last part, in triangle ABC and triangle DEF, AB is equals to DE given to us, BC equals to EF, both of them are given to us in the question. Can you see that? This triangle and this triangle. AB is equals to DE given, BC equals to EF given. And is the third side AC equals to DF? Proved above. AC is equals to DF. And AC is equals to DF. Proved above. So therefore, triangle ABC is congruent to triangle DEF by what congruency? SSS. Right, students? So it is very easy if we can observe the questions. If we do not observe the questions, then it becomes difficult for us. Observation in geometry is very, very important. You have to observe the questions carefully. See, only 3 questions we have done. And all 3 questions are based on the understanding of the last chapter, congruency. This entire chapter is based on the congruency, properties of congruencies of triangles. So that is why that chapter is very, very important, as I said. Right? So today you have to see the theorems of 8 chapter theorem from 8.1 to 8.10. In the document section you will be able to see. Right? You can go through the theorems in your textbook also. You can recall them. You have to apply them again and again. And please do these 3 questions in your notebook. Rest of the questions we shall discuss in the next video. Thank you.